ignore. Overlap all. Oh, it's because I'm dumb. That's why. So I forgot to actually set the custom collision here to pass through. Just so you know, you kind of need to make sure that if you're going to mess with object types, you actually set the object type. Don't do what I just did and not set it, or it's not going to work, and then you're going to get frustrated, kind of like I did. See, there it goes. And as you can see, that's actually, if you see that jarring, that's what I was talking about with the camera. So I just need to figure out why that's doing that. What are you doing? Where is the thing that I need? No, we don't need that. Don't need any of that. Let's uncheck collision test. See if this works. I believe this is what I did. Yeah, there we go. Now you can jump through. But that leaves us with the problem of a useless platform. At least useless, whenever you actually cross it. So, we're going to come in here. And we're going to copy all of this. Boop. And overlap. Set this, set this. And as you can see, it's pretty much just the exact opposite. What we're going to do is we're going to drag off of return value z, do a less than, or do a greater than, rather. So, in this case, if it's the player character, and the player character is greater than the z value when it crosses, or when it ends the overlap, I'm going to set the pass through the block. So, we come back, get on the elevator, jump, and so first, it works, yay, it's a platform, we can stand on it. Hey, look, we can pass through, and now it's back to being a platform that we can stand on. Woo! That is... actually, I believe... Yeah, you can just reverse the pins. I just like to make sure it's consistent. TK4 asked if you could just reverse the pin so it'd still be less than, but it'd be if static mesh is less than actor location instead of if actor location is less than world location. That's perfectly fine if that's how you wanted to do it. I prefer this for consistency. But yeah, great point. Let's see. There was one other thing I added to it, and there's no guarantee this is going to work because it actually didn't work until I had someone else. You know what? I'm going to wait until I figure out exactly why that was working before I do that. Because it didn't work yesterday, or 2 days ago, and then today it was all of a sudden working, and it was, if you press down twice, it would drop you back through the flooring, which, it's cool, but it's not that big of a deal. But in this case, that is a working one-way platform. So if you ended up needing those for a 2D game or even a 3D game, whatever you're trying to do for it, just boom, and you go in one way, can't go back down. And you can do that, if you had a wall that you only wanted it to go through. You're passing from a negative y value to a positive y value, and if you're at a less than y value, then you can pass through, and then you can't go back if you're already past that point. So like checkpoint blockers or anything like that, where you would want the player to stop moving backwards, that's a good way to do it. There's all kinds of ways to do that, but that's definitely one way that is perfectly viable. Okay, so that's that one. Now comes the complicated one that was really fun to put together. I'm going to need my beer for this, and I came prepared today. I have a beer, so we're going to be drinking during this. Because this was a little pain in the ass to set up. I'm not going to lie. And that is random movements on blocks. One of our users had asked if you could create, if you remember like Mario 64, the platforms that would move and it seemed like it was random intervals all over the place. Really cool stuff. Thing is, not actually random. Those platforms were all probably programmed with specific numbers to make it seem random, but it wasn't actually. So I've created something that's similar and can be implemented in quite a few things. I had a lot of help from Ian Shodden, so shout out to him. He helped me out pretty much with the entirety of this because I couldn't figure out how to get it to work. But big shout out to him for that. So I'm going to come over here to a empty location so we could see this, because it's not actually going to be in my level. First thing we want to do is create two blueprint classes. One is going to be our platform mesh, and the other one is going to be the actual mover. So let's call this moving platform. Got lots of platforms. And then this one's going to be called platform mover. Alright, cool. Moving platform. Obviously going to go ahead and get that scene component right back in there so I can adjust as I want to. We're not actually going to be adjusting anything, I prefer to have it in there just in case. Get a static mesh, and we're going to make this a simple cube. Cube will work. Okay. Now go to our event graph, and let's see, we're going to create two vector variables. The first one is going to be your original location. The second one is going to be the offset. So original location, we're going to go ahead and get the offset. Oh. I didn't want to duplicate here. Oh, look, there's an error. Offset. There we go. So don't name two variables the same thing, or you'll get that duplication error, and you have to rename one of them to get it to undo. It's kind of annoying, but you kind of expect. And I'm going to show a 3D widget so that we can actually see this in the editor when we do the viewport. Okay. Event begin play. Going to set the original location, and we're going to set that here. And let's see. So that is all that's going to go on event begin play. Then we're going to come down here, going to make a custom event. We're going to call that move me. That's going to go directly into a flip-flop node, which what a flip-flop does is every time you run the event, it's either going to run A or B, whichever one it was most recently running. So it's like, okay, A, run the event, B, run the event, A, run the event, B, kind of thing. Pretty easy to go to grasp. It's not a very difficult node. The name confuses some people sometimes, but it's honestly exactly what it sounds like. Okay, let's see. We're going to need two sequence nodes. One in A, one in B. Then we're going to need two gate nodes. And the sequence, as opposed to the gate, where the gate flips between, or the flip-flop flips between the two, the sequence does each. It goes, okay, you're going to do this first, then do this. That's the main difference between sequence and flip-flop there. So plug sequences, the first sequence is then 0 into the close of the second gate, plug the then 0 of the second sequence and put it into the close of the first gate. Oop, didn't mean to open that macro. Sorry about that. Then we're going to take the 1s and plug them into the opens. So then the then 1 of the A flip-flop is going to go into the first gate. Then 1 of the B flip-flop is going to go into the open of the second gate. Now we need one more sequence here. And event tick. Yep, I'm using it. I am using the event tick. Only because it isn't going to be overly performance heavy for me to do this. So that is why we are using event tick. Forgive me. Okay, so that is that. Now let's see. We need to scroll over here. We're going to get a set actor location. Copy and paste that. Why did it give me add actor world offset? That's not what I wanted. I wanted set actor location. There. That's what I wanted. Plug one into each of your gate nodes. Now, get to mess with a very fun node called vinterp, which is vector interpolate. Hey TK4, I'm glad to hear your rotations are working. I told you, man, tick will mess you up if you're not careful with it. Once you get rid of that tick, everything works better. But in this case, we actually need tick because we want it to be checking on frame, which sucks. I really don't want to use tick, but get world. Okay, now here, the vinterp, that's vector interp, which allows you to move or do something between two vectors at a specified time, which we're going to use get world delta seconds. And then the interp speed, which sets how fast the object or whatever you set moves between those two vectors. So in this case, we're going to do something like 5. And you want to make sure that you use the same numbers for both of these, or it could be problematic. And you'll see why in a little bit. Okay. So for both of them, get actor location. And we're going to use target self. And let's see. For this one, we want to do get actor location plus vector offset. So we're getting the actor's location, which should be your original location, adding whatever you set the offset value to, and then interpolating between those at delta seconds for an interp speed of 5 to set the new location. Let's clean that up a little bit. This one's a little bit easier, since this is the way this works is A is going to be the move up on your blocks, and B is going to be the move down on your blocks. So you've already set what your original location is. Right? So now, sorry, I messed this up just a little bit. We want to actually get actor location. There. We're setting the original location to your actor location. That I messed up there. So the second one, we're getting the new actor location and then moving back to the original location. So it's just an up and down. Very, very simple. Okay, and that is the beginnings of this. This is pretty much all you're going to need in your actual platforms. The rest of it is going to be done in your platform mover. And let's see, get rid of this, get rid of this. Where are you? Platform mover. Okay, all you need for components in this is a collision. I'm going to use a box collision because it doesn't really matter what you use. but I like box collision. It's very simple to use, very